Hi students, this video is going to be part 1 of part 2 about chi-square. There are 2 different types of chi-square tests that we are going to talk about. And the first one is going to be the chi-square test of independence. Okay, the one that we're going to be talking about after this in part 2 will be the test, the goodness of fit test. Test of independence. All right. This one here uses a contingency table. And is commonly used to determine whether or not there is a significant difference between 2 categories, so mitosis and interphase, when a variable has been introduced. The variable within this example is going to be lectin. All right, so if we take a look, I'm going to go to the PowerPoint real quick. And let's just actually write down that contingency table. This contingency table can be found in your lab manual on page 131. And so if you take a look, use a different marker for this one. Okay. And so for this one here, you have interphase and you have mitosis, you have your control, and you have your treated. So in order to figure out your expected values, now remember, we're going to put our expected values up here. Actually, let's do this. Let's put our observed. Okay, so our observed values, again, we have our control. We'll use that as C and T. And then we'll do I and M for interphase and mitosis. All right, so for those, we had 148 in interphase and 25 in mitosis. We had 161 in interphase and 88 in mitosis. Now, for a chi-square test, you do need expected results in order to figure out your chi-square number. So for expected, again, you're using a contingency table instead of ratios, which would be in a goodness of fit test. So with your expected, again, we have our control and we have this is going to be interphase, and this is going to be mitosis. All right, so in order to figure out interphase, you're going to do, and this is again found on 131. So you want to do your control. Actually, and you know what? No, we'll do that. Control total times interphase total. Okay, over total of all. This is going to be your control total times your mitosis total over total of all. So I could probably make this a little bit bigger so I can fit all those words in. So control total times your mitosis total over total of all. Now, if you were ever to want to figure out a chi-square test of independence, the contingency table would always be given to you. It's not something that you would have to ever memorize. All right, so this one here, you would have your treated total. So let's get rid of that. Treated total times your interphase total over total of all. And what do you think goes here? Exactly, your treated total times mitosis total over total of all. So all of these numbers are going, all of that formula is going to get your expected number. So once you've done all of that math based off of what you have observed, then you can plug those numbers in. So you should get 127. You should get 46 for that. 179 and 67. So we now have our observed, we have our expected, and we got our expected from our contingency table. Now let's move on to the actual chi-square. Now, you can set up your chi-square table multiple ways. I like to do it where your chi-square kind of goes down. Some people have it where the chi-square goes across. Again, it doesn't really matter as long as you have the right number of lines. For your quiz, you will not need to write this down as far as the formula, but in your exam, you will need to create your own chi-square table. You will need to memorize all of the steps. Okay, so this is your observed, this is your expected, observed minus expected squared, observed minus expected squared over expected, and your sum. All right, so we're going to do that. So this is your observed, expected, observed minus expected. This is also called D, or your deviation. Observed minus expected squared, and then observed minus expected squared over E. Now you have categories, right? So you have your control interphase. You have your control, let's see, mitosis, do M. We have our treated, like to sneeze. Okay, treated interphase and our treated mitosis. All right, so why don't we go through our observed? So for our observed, our control, that's 148. Again, we're getting numbers from there. And our expected is 127. Our controlled mitosis is 25. And our expected mitosis for our control was 46. Our treated was 161 and 88. And our treated was 179 and 67. once you do all the math out here, so this is going to give you 21, negative 21, negative 21, 21, 21, 441, 441, 441. All right, and then the last set of numbers are really important. So this is going to be 347, 959, 2.42, and 6.58. You are going to take all of these numbers and you are going to add them to get a single number. That's going to give you your sum. The sum ends up coming out to be 2206. Okay. Now the purpose of the chi-square is to, so this is the test of independence, this is to reject null hypothesis. Because you want there to be a statistical difference between the two. You want there to be, okay? You've got this number, great. Now what do? You need to look at the critical value. There's a critical value table that you are looking at. And in order to know which column you are focusing on, you need to figure out the degrees of freedom. Degrees of freedom are going to take the number of result categories, -1, times the number of variables, -1. So we have 2 variables, so 2 minus 1, and we have our control versus treated. So that's also going to be 2 minus 1, which gives you one degree of freedom. You're going to look at your critical value table, which is in, sorry about my puppy, he is crying. So that's going to be in your book. And we're going to be looking at the probability of 0.05. That gives you a 5% probability. That would be, this would happen to chance. And so we are looking at a number of 3.84. So you're going to compare 3.84 to 22.06. If this number is bigger, so if this number is bigger, you can reject your null hypothesis and say that there is a statistical difference between the two. Hopefully that was really helpful. Stay tuned for part 2. I will do that probably a little bit next week, but this should help you finish up your pages in your lab manual. Have a great night.